In this video, I want to review how to solve quadratic equations using the quadratic formula. Now, as you should remember from class earlier this semester, we actually programmed the TI Nspire to execute the quadratic formula for us. There are web-based tools that would allow you to solve these as well. However, you don't have access to the internet for your test. So I'm going to make sure that you're aware of how to use the Nspire to complete this process. And what I would recommend before your test is that you write down these expressions from the calculator screen, because if you recall, all we need to do is type this expression into your calculator, and the calculator will store QFP as a command and allow you to execute the quadratic formula with the plus sign, and then copy and rewrite it, change the QFP to an M, and then change this sign to a minus, and then the calculator will have a program that will execute the quadratic formula with a subtraction sign or a minus sign. The quadratic formula in its definition must be executed twice in order to identify all solutions to a quadratic equation, and so it's nice to have both of these defined here. Also, by prepping your calculator first, it makes solving this number of problems pretty easy. When you've got 10 problems in a row that must be solved using the quadratic formula, this tends to be pretty straightforward. Now, of course, with the quadratic formula, we must have a quadratic equation set equal to 0, which we have in 34 and 36. But for a problem like 38, we don't have an equation equal to 0. So the very first thing that I'm going to do is subtract 2 from both sides, and now we do have an equation equal to 0, and it's quadratic. We know that it's quadratic, or we call these equations quadratic when the largest exponent is 2. So again, we've got a quadratic formula here, or quadratic equation. We have one here. Oops, I have to add 2. I almost made a mistake there. I'm adding 2 to both sides, so that leaves me with minus 1. And in this last example here, I'm adding 2n to both sides. And that leaves me with 5n squared plus 5n minus 7 equals 0. So now that we've got these equations set up in true quadratic form, these are quadratic equations that equal 0, we can identify our a, b, and c values for each one. And this would allow us to execute the quadratic formula a little bit more quickly. Oops, almost made a mistake here again. 4, 3, negative 8. So on the test, I'm asking you to show your work. In a problem like number 34, we didn't have any prep work involved, but what I would like to see is that you recognize that a is equal to 2, b is equal to negative 3, and c is equal to negative 20. That way I recognize that you understand the negative symbols are a part of the coefficients. And then you can show this QFP. And I think since we wrote these down, I think it would be fine for you just to say QFP equals and QFM equals. And this is where we'll report our results from the quadratic formula with a plus sign and the quadratic formula with the minus sign. So I'm going to jump over to the calculator now, and we'll type QFP, quadratic formula plus, and you'll notice that the phrase changes to a set of bold letters when you've typed it correctly. And the numbers that we're entering are 2, comma, negative 3, comma, negative 20. And here's our solution for the quadratic formula using the plus sign. When we press the up arrow twice and tap the enter key, that copies the prior formula down. And I'm going to change this from QFP to QFM. Now I think that's faster than typing QFM and writing the same 3 numbers again. And when I press enter here, I end up with negative 2.5. So there are my 2 solutions. The positive solution, or I'm sorry, the solution when using the plus sign is 4, and the solution for when using the minus sign is negative 2.5. Now I do want to be a little bit more careful here. maybe we shouldn't use the equal sign here, but an arrow instead. This would be my way of saying the QFP gives us the solution of 4, and QFM gives us the solution of negative 2.5. But what we're really saying is that n is equal to 4, and n is equal to negative 2.5. Those are the two numbers, and the only two numbers that exist in the universe that, when substituted into this equation, will make it equal to 0. So when you substitute a 4 in place of n, you'll get an equation that equals 0. And when you substitute 2.5 into this equation, you'll also get an answer that equals 0. There are no other numbers that will make that happen. So that was a bit of a lengthy conversation just to answer one problem. Let's see if we can go faster with number 36. I'm going to say that a is equal to 1, b is equal to negative 2, and c is equal to negative 24. So when I execute the quadratic formula with a plus sign, I'll get a result, and the quadratic formula with the minus sign, I'll get another result. So this time I'll type QFP again because I'm using new numbers, and we've got the number 1, comma, negative 2, comma, negative 24. Execute. So that solution is 6. If I execute the same equation again, or command again, this time with a minus sign, I'll end up with negative 4. So we have 6 and negative 4, and those are the results for B. For number 38, I'm going to say that A is equal to 4, B is equal to 3, and C is equal to negative 8. So when I run the quadratic formula with a plus sign, I need to execute it with the number 4, comma, negative 3. Oops, sorry, I think that's a positive 3. And negative 8. And then we'll execute this again using the minus sign instead of the plus sign. So we'll change P to M, and we get this result. Whoops. On my calculator on screen, since it's the advanced version of our calculators in the classroom, I have to keep pressing Control-Enter in order to get decimals. I think your calculators are set up so that that's not the case. Now, if you recall, I prefer to see 4 decimals as part of my answer, and we'll round to this 4th spot. So we'll call this 1.0881. K is equal to 1.0881, and K is equal to negative 1.8381. And this was the result from the quadratic formula positive, and this was the result from the quadratic formula, not negative, but minus. Quadratic formula plus and quadratic formula minus. Those are the two solutions we're after. With number 40, I think A should be identified as 1, B is identified as 3, and C is identified as negative 1, because we're looking at the coefficients here after we've got the equation equal to 0. And we need a result from the quadratic formula with a plus sign and the quadratic formula with a minus sign. And so that's going to tell us our two solutions. When we run quadratic formula plus, put my cursor back where it's supposed to be, quadratic formula plus with 1, comma, 3, comma, negative 1, we get this result. And when we re-execute the equation this time, or the expression this time with a M instead of P, we get this result. So one of them is 0.3028 when rounded, and the other is negative 3.3028. Last one for this group, and it looks like we might be able to finish these 4 most recent problems in as much time as it took to complete the first one. So clearly the setup is a bit time consuming, but the benefit in taking that extra time makes this makes the remaining questions go much faster. All right, so I'm going to use an A value of 5, a B value of 5, and a C value of -7. So QFP 5, comma 5, comma -7. Oops, again I need the decimal answer, so there we go. And if I execute this again with a minus sign, so M, I got this result. So we've got 0.7845 for one solution and -1.7845 for the other. And so, again, the quadratic formula is a very convenient and quick way to solve quadratic equations. The only time-consuming part with that is programming your calculator to do so, or finding a tool that's got that program already built in. I think this is a good stopping point for this video, so thanks for watching.